Hey guys, this is a video on historical perspectives of physics. Introduction. Physics, as a field of science, has evolved dramatically over the centuries. From the ancient Greek philosophers to modern-day physicists, the study of the natural world has been marked by revolutionary ideas and transformative discoveries. This video traces the historical development of physics, highlighting key figures, discoveries, and theoretical advancements. Ancient and classical periods. Pre-Socratic philosophers. Thales of Miletus c. 6-546 BCE. Often considered the first physicist, Thales proposed that water is the fundamental substance of all matter. Anaximander c. 6-10-5546 BCE introduced the concept of the apeiron, infinite or boundless, as the origin of all things. Heraclitus c. 535-475 BCE suggested that change is the fundamental essence of the universe, famously stating, "You cannot step into the same river twice." Classical Greek period. Democritus e. 60-370 BCE proposed the atomic theory of the universe, suggesting that everything is composed of indivisible atoms. Aristotle, 384-322 BCE, developed a comprehensive system of physics that dominated Western thought for centuries, emphasizing the four elements earth, water, air, fire, and introducing the concept of natural motion. The Middle Ages Islamic Golden Age. Al-Hazan, Ibn al-Haytham, 965-1040 CE, made significant contributions to optics and the scientific method, particularly through his work, Book of Optics. Avicenna, Ibn Sina, 980-1037 CE. His works on physics and philosophy influenced later medieval European scholars. European Middle Ages. Roger Bacon, 1214-1294 CE, an early advocate of the scientific method, Bacon emphasized the importance of empirical evidence and experimentation. Thomas Aquinas, 1225-1274 CE, integrated Aristotelian physics with Christian theology, influencing medieval scholasticism. The Renaissance and early modern period. Copernican Revolution. Nicholas Copernicus, 1473-1543, proposed the heliocentric model of the solar system, challenging the geocentric model that had prevailed since Ptolemy. Galileo Galilei, 1564-1642, used telescopic observations to support the heliocentric theory and made foundational contributions to kinematics and dynamics. The birth of classical mechanics. Johannes Kepler, 1571-1630, formulated the three laws of planetary motion, which describe the elliptical orbits of planets. Isaac Newton, 1643-1727, published Philosophiae Naturalis Principia Mathematica, laying the foundation of classical mechanics with his three laws of motion and the law of universal gravitation. The 18th and 19th centuries' development of analytical mechanics. Joseph Louis Lagrange, 1736-1813, developed the Lagrangian mechanics, reformulating classical mechanics using the principle of least action. The Lagrangian function plays a central role in this formulation. William Rowan Hamilton, 1805-1865, introduced Hamiltonian mechanics, an alternative formulation of classical mechanics. The Hamiltonian function provides a powerful framework for understanding dynamical systems and is foundational in the development of quantum mechanics. Thermodynamics and statistical mechanics. Sadi Carnot, 1796-1832, laid the groundwork for the second law of thermodynamics with his analysis of heat engines. James Clerk Maxwell, 1831-1879, developed the theory of electromagnetism and introduced the Maxwell-Boltzmann distribution in statistical mechanics. Electromagnetism and wave theory. Michael Faraday, 1791-1867, discovered electromagnetic induction and contributed to the understanding of electric and magnetic fields. Heinrich Hertz, 1857-1894, demonstrated the existence of electromagnetic waves, confirming Maxwell's theory. The 20th century quantum mechanics. Max Planck, 1858-1947, introduced the concept of quantization of energy, leading to the development of quantum theory. Albert Einstein, 1879-1955, explained the photoelectric effect, leading to the development of quantum theory, and formulated the theory of relativity, fundamentally altering our understanding of space and time. Niels Bohr, 1885-1962, developed the Bohr model of the atom, integrating quantum theory with atomic structure. Relativity. Albert Einstein formulated the special theory of relativity, 1905, and the general theory of relativity, 1915, revolutionizing the concepts of space, time, and gravity. Particle physics and the Standard Model. Enrico Fermi, 1901 to 1954, conducted pioneering work in nuclear physics and developed the first nuclear reactor. Murray Gell-Mann, 1929 to 2019, proposed the quark model, leading to the development of the Standard Model of particle physics. Contributions from India. Ancient Indian contributions. Canada, c. 600 BCE, an ancient Indian sage who proposed the atomic theory, suggesting that everything is composed of indivisible particles called Anu. Aryabhata, 476 to 550 CE, made significant contributions to mathematics and astronomy, including the concept of zero and the approximation of pi. Modern Indian physicists C.V. Raman, 1888 to 1970, discovered the Raman effect, which explains the change in the wavelength of light when it is deflected by molecules. He was awarded the Nobel Prize in Physics in 1930. Satyendra Nath Bose, 1894 to 1974, worked with Albert Einstein to develop Bose-Einstein statistics, which describe the statistical distribution of identical particles with integer spin, now called bosons. Homi J. Bhabha, 1909 to 1966, known as the father of the Indian nuclear program, Bhabha made significant contributions to quantum theory and cosmic ray physics. He played a key role in setting up the Tata Institute of Fundamental Research, TUFR, and the Atomic Energy Commission of India. Meghnad Saha, 1893 to 1956, developed the Saha ionization equation, which explains the physical and chemical conditions in stars. Vikram Sarabhai, 1919 to 1971, considered the father of the Indian space program. He established the Indian Space Search Organization, ISRO, and contributed significantly to the development of India's nuclear and space capabilities. The late 20th and early 21st centuries advances in cosmology. Edwin Hubble, 1889 to 1953, demonstrated the expansion of the universe, leading to the Big Bang Theory. Stephen Hawking, 1942-2018, made significant contributions to black hole physics and cosmology, particularly through his work on Hawking radiation. Modern theoretical physics. Richard Feynman, 1918 to 1988, developed quantum electrodynamics, QED, and introduced the Feynman diagrams. Peter Higgs, b. 1929, predicted the existence of the Higgs boson, a fundamental particle confirmed by experiments at CERN in 2012. Conclusion. The history of physics is a testament to human curiosity and ingenuity. From ancient philosophical inquiries to the precision of modern particle physics, each era has built upon the discoveries of the past, continually expanding our understanding of the universe. Contributions from Indian physicists have played a significant role in this journey, adding to the global heritage of scientific knowledge. As we move forward, new theories and technologies will undoubtedly continue to transform the field, revealing deeper insights into the fundamental nature of reality.